In section 1.3 of Unit 1, we're going to look at rational numbers and decimal representation. And a quick look at the booklet, you'll see that I do give you some of the key representations of rational number and properties and cross-product test and things, and then we get interspaced with some examples. Again, you want to show the work of how we get there. All right. Now we'll build some vocabulary, definition, and fundamental property. Again, you don't have to write these down at this time. They will be coming up as we get to them. Okay. What is, once again, a rational number? And in set builder notation, its x is such that x is a quotient. Remember we said this was a fraction of two integers with the denominator not equal to 0. Now that was one of the definitions. And I'll go back because I want to review these where in its fractional form converted to decimal fraction, the fraction terminates, and also for others in fractional form, when we go to a decimal fraction, the fraction part repeats. And a repeating pattern or a terminating pattern is also used to define rational numbers. All right, now we'll go on. Now, another definition that is often referred to as simplifying rational numbers to lowest terms is something like this. Now remember, you can't have a denominator that contains zeros as factors. But when we tease apart a numerator into its factors and a denominator into its factors, we see that if we end up with factors that in the numerator are the same as in the denominator, we can think of canceling them out. And this anything divided by itself, as long as it's not 0, is 1. So this relationship can be simplified to A over B. Now, we're going to be using that as we go on a little bit too. Let's continue. We want to write, and this is our first example, so you ought to include that in your notes, as example 1 PP, that they're from our PowerPoint. And let's tease this apart. So, if we're wondering what are the factors of 24, a little technique we use is this. We put 24 there, and then we say it's even, so we can take out a 2. And that becomes a 12. And this is even, we can take out a 2. And that becomes a 6, a 2, and this becomes a 3. Now these are what we call our prime factors. These are all prime numbers. Now when we go to the 27, it's not even, so you can't take out a 2. But notice if you add 2 and 7 together, it adds up to a 9. Now, is 9 divisible by 3? Yes. So we're using what is called the rule of threes. That is, if we add up the digits and the sum of the digits is divisible by 3, then this number is divisible by 3. And then take a 3 out of there, and we get a 3 out of there. So we're going to now put these along the top here. 2 times 2 times 2 times 3. That would be 24. And then here we have 3 times 3 times 3. Now, we're not going to do this generally, but I wanted to show you the process. And notice the only common factors in the numerator and the top and the denominator are this one set here. So then this is going to end up being 8, and this is going to be a 9. Now, you might say, well, couldn't we have just taken, let me write this again here, 24/27. Take a 3 out of there and get 8. Take a 3 out of there and get 9. Yes, that's the usual way of doing it, but this is the strategy behind it. Okay, you're now having a fraction, a rational number, to its lowest terms. Let's go on. We went back a little bit there. Okay. Now, another kind of background item is the cross product test for equality of rational numbers. And to put this simply, if you have A over B, which is a fraction, and that we're saying is equal to C over D, which is a fraction. This is sort of an equation that we can, in a sense, check the equivalency of A times D, which would then make it AD, and then B times C, which is BC, and these values should equal each other. Now let's give you a little example of this. So this is 1/2, and this will be 4/8. Now we know 1/2 and 4/8 are equivalent. And let's try the test. So 1 times 8 would be 8, and 2 times 4 would be 8. And that's what they're illustrating here. Now for our quiz question, one of the ones I use once in a while is, what are A and D called? They have a special name for this. And the answer is called the extremes. Because if you start this way, 1, 2, 3, 4, this is 1 and 4, sort of the extremes. And then the ones in the middle, 2 and 3, which are BC, would be called the means. And the statement we often use is this: the product of the means equals the product of the extremes. Remember, product is multiplying factors, and we've defined now the extremes and the means, and we've given you a simple proof. Now this is a technique we will be using in this course. So let's go on. Now, when we are adding and subtracting fractions, the rule is we have to have the same denominator. And I'll do this with you, and you can write this as an example. A plus B plus now C plus D. we want to add these up. But notice our denominators are different. So the technique for this, and I'll change colors, is, you recall from an earlier lesson that we are allowed to multiply anything by 1 and it doesn't change its value. But 1 can take many different forms. A form of 1 is 1 over 1, 2 over 2, 3 over 3, 4 over 4, and you could keep going on and on and on. These are all 1s. Anything divided by itself, so long as it's not a 0, are 1s. So we want to make this term to a term with our common denominator. Now our common denominator would have to contain a b and a d, because this is a denominator of our individual fractions. Now how do I make this term here with a denominator of bd? Well, again, I have to multiply it by 1, but what form of 1 would I use? Well, in this case, you're going to use d over d, which is another form of 1. So I'm going to multiply this by d over d. Now it has that common denominator. Well, what do I need to multiply this one by to have it get this denominator? And again, I have to multiply it by 1. Well, what form of 1? And if you're thinking b over b, you're thinking correct, and that's what we're going to do. So b over b. So now our denominators are the same. So now we just symbolically add our numerators, which would be AD plus BC. And that is what they have here. Now the only thing they're not showing you is how they did it. That's why we have classes and instructors to go over to help students develop this. Now if it's subtraction, it's done the very same way. You're going to multiply this by 1 in the form of d over d, and this by the form of b over b, and then you just symbolically show the form of subtraction. All right, let's continue, because I'm sure they're going to give us a problem here. So, adding and subtracting numbers, we need to find the least common denominator so our denominators can be the same. So, one is addition, one is subtraction. So let's take a look at this. Now, what will be our least common denominator between the two of these? Well, it's not any of these. And you might say 30. 9 doesn't go into 30. In fact, let me show you the process. And we use that similar way of what we did before. Well, we know this is 3 and a 3 here. And here we have a 3 and a 5. Now, the protocol for finding this is, as we look at the prime factorizations outside here, what is the greatest time, the number of times, that the 3 is used as a factor in any one factorization? Well, the 3 here is used, in this case, twice. Here it's only used once, so we need to use it twice. We need to show it as part of our common denominator the greatest number of times it's used in any one factorization. And then the other factor is 5. The greatest number of times that 5 is used in any one factorization is once. So we have 9 times 5. Our common denominator is going to be 45. And that's for both of these, since they have the same example. So now we're going to multiply these by 1, and I like my red here. So what form of 1 are we going to multiply this one by? So we end up with a denominator of 45. Think about it. And if you said 5 over 5, that is correct. 9 times 5 is 45, so 4 times 5 is 20. And this one's a plus. Now we want to make this denominator 45. What do I multiply it by? What form of 1? And if you said 3 over 3, you have it. 15 times 3 is 45, and 2 times 3 is 6. So now we have our numerators over a common denominator. This is going to be 26 over 45. Now we could take a 3 out of there, but not out of there, and we could take a 2 out of there, but not out of there. So this is our answer. We've simplified that to lowest terms. Now over here, we're going to use the same protocol. 5 over 5 and 3 over 3. So this will be 20 minus 6. So 20 minus 6 is 14 over 45. And again, that can't be simplified anymore. Now, one of the nice things about our flipped classroom video program is you can go back and watch it again. And there are the answers. Let me move it down just a little here. There we go. Now, when we are multiplying rational numbers, the protocol, and I think we can see it right here, is that if you have your fractions, here you don't have to worry about the denominators. There's no common things that you can cross-cancel. You just multiply your numerators, multiply your denominators. So here's a typical example. And this is number 3, so be sure you're putting that in your notes as example 3 PP, so you have reference to it. So this will just equal, notice we can do some cross-canceling though here. I could take a 5 out of there, goes once, a 5 out of there, and that goes twice. A 3 out of there, and that goes once. A 3 out of there, and that goes 3 times. So 1 times 1 is 1, and 3 times 2 is 6. So this simplifies to 1/6. Now if you did it the other way, 5 times 3 is 15, and 9 times 10 is 90, you would have to simplify that until you ended up with something like this. In fact, you could take a 15 out of each one of these. But if you do the cross-canceling first, then once you get a results, you can't take anything out of this anymore. You've taken it out through cross-canceling. It's what we've illustrated there. And they're showing it the long way. I like the short way. Now, division of fractions gets to be a little challenging. We're saying if we have 1 over b, that in a sense equals a over b, a times 1 over b. It's another way to write it, but I will show you the protocol. And we'll illustrate it here using the letters, and then I will illustrate it using an example. And this is what you'll want in your notes. So here we're saying a over b divided by c over d. Notice this is not multiplication, this is division. Now the protocol for dividing fractions is to convert the fraction from a division problem to a multiplication problem. The first term, the first factor here, stays the same. We change the sign from division to multiplication. And what have we done to the second factor here? We've flipped it. We've taken its reciprocal. The d goes on top, the c goes on the bottom. And then we just multiply. And of course we can cancel out wherever we can. So division of fractions is similar to the multiplication of fractions. We just have to convert the division to a multiplication problem, changing the sign and then flipping the second term. Let's go on. So, again, this is example 4, PP, and will look like this. 2/9 divided by 5/6. Now the first thing we have to do is change it to multiplication. First term stays the same, 2/9. We change the division to multiplication, take the reciprocal of this or flip it over. Now we're going to cross cancel wherever we can. I'm going to take that arrow out of there so it doesn't confuse us. 3 will go into 6 twice. 3 will go into 9 3 times. And that's all we can do. So 2 times 2 is 4. 3 times 5 is 15. And there's our answer. Now notice they're not cross-canceling initially, which I think makes it a little easier. And then you have to tease it apart later. I think it's easier when you do it earlier. Okay, another important background item, density property of rational numbers. Now, density refers to how many are like in a particular area, the density of something. Now, if r and t are distinct rational numbers, with r being less than t, what is in the middle of those two? Well, what they've done is they've separated this by putting the s in the middle. So they're saying r is less than s, s is less than t. Now, how many items, and it would be fractions in a sense, would be in the middle? You might say, is there just one fraction there, or 3, or 10, or 100? And the answer is there's an infinite number of fractions that can be found between any two numbers. So this is a concept. And there might be a quiz question in regard to the density property of rational numbers. How many fractions can be between any two rational numbers? And the answer, there's an infinite number. because you can keep making that denominator bigger and bigger and bigger and bigger and bigger. And it goes on to infinity. Okay. Now, but what we can do is find a number that is halfway between any two numbers on either side. Now we call that the arithmetic mean. Again, this is a background word. What is the arithmetic mean? It's the average of two numbers that are on either side of something. So how do we do that? Well, we take the two numbers, add them together, and then divide by 2 to find what is halfway there. Well, sometimes this is easier said than done, but I'm going to show you. This is example 5pp here, and let's work it out. So we have 3/5 and 2/3. What is the number halfway between? That is the arithmetic mean. Well, basically to set it up, we're going to have to add these two together, and then we're going to divide by 2. So that's where we're going. But first we have to find out what this is. Now, this one's a little bit long, and I want to change colors so we can see. Well, let's do just the top part to find out what that is. So what will be our lowest common denominator between a 5 and a 3? Well, since these are prime numbers, just multiply them together and you get 15. So we're going to have to multiply this by 1 to get our denominator to be 15. So this is going to be a 1 in the form of 3/3. And this one we're going to multiply by, say it, 5/5 to get a denominator of 15. So 3 times 3 is 9, plus 2 times 5 is 10. So our answer here is 19/15. But now we want to divide that by 2. That is, take 1/2 of it. What is 1/2 of this? Well, we're just going to multiply it by 1/2. Now, notice, can you do any cross-canceling? No. So this is going to be 19/30. So the arithmetic mean between these two fractions is 19/30. We found it by adding these two together. This is what we did here. And then dividing by 2. And they showed us a little earlier, dividing by 2 is the same as multiplying by 1/2. 1/2 of something is dividing by 2. Okay. Let's see what they show us here. So there's the 19/15. Notice they're not giving us the detail of it. And then we multiply by 1/2. Or in a sense, we're dividing by 2. Multiplying by 1/2 gives us 19/30. Very good. Okay. Now, something we reviewed earlier, and they're reviewing it again. We say that the decimal form of rational numbers either terminates, this one, that is, it stops, or has a repeating pattern, a recurring block of numbers as decimals. Now, there is a background item that tells you about this, and here it is. So you want to take some notes on this. We say a rational number in lowest terms, it has to be in the lowest terms, results in a terminating decimal if the only prime factors of the denominator is a 2 or a 5 or both. So it can only have 2's or 5's or both once you get the simplified fraction and you're looking at the denominator. Now, other rational numbers, if it has a 2 and a 5 but some other number, such as 3 or 7 or 11 or something, then it is not a terminating decimal, but would be a repeating decimal. So these are the words that I would write as notes. Again, you can pause. But let us check this out. So again, this is 6 pp for our example from the PowerPoint slides. And we're looking at 15 I should say. Now, we know this is going to be 3 times 5. And let's look at this one, 16. Well, 16 is 2 times 2 times 2 times 2. Now, is this one going to repeat or terminate? Well, it has a 5, but it also has a 3. So in its simplified form, this one will repeat. Now, this one, letter B, has 2, 2, 2, 2. Only has 2's. Doesn't have any 5. Well, it doesn't have to have a 5. If it only has 2's, this one will terminate. Okay. It's sort of an easy one here. And there's the solution. Okay, we're now going to go through these answers. Again, these are in your booklet. You can show the work there, and you want to give it your best shot. Now, sometimes it's hard to figure out what the prime factorization may be here. So I suggest, use different ways. You can use this method here. We'll do it one more time. This is even, so we know we can take a 2 out. And that's 18. That's even, we can take a 2 out. And then we get 9. And then we get a 3 and a 3. So these are the prime factors of the 36. And 54 is even. You can take a 2 out and get 27. Now here you can't take a 2 out, but using that rule of 3s, 2 and 7 add up to 9, we can take a 3 out. So we can 3 times 3 is going to be a 9. And a 2. 2 and 9 is 18. So theoretically, we could take an 18 out of each one. So this would be 18 times 2 here. That should be multiplication. And this is going to be 18 times 3. Now, there's other ways to do it, too. But now your 18 over 18 cancel out and give you a 1. So the answer for this one is 2/3. And there you go. Now, for this one, what's our common denominator going to be? you said 30, you hit it right on the nail there. So we have to multiply this by 2 over 2. That's our 1. And here we're going to multiply this one by 3 over 3. So this is going to be 4 over 30 plus 3 over 30. So this gives you a 7 over 30. Now, this one's a little bit of a challenge here. I could do it, but let me show you what the book does here. And if it does a good job, we will just use it here. So, first of all, you had to figure out, there's our 7 over 30 for the first one. What's the lowest common multiple? We had to use that technique that we showed you. Generally, you're not going to get any of this difficult. And for sure on your test, you're not going to get any like this. But your lowest common denominator works out to 3,600. So you have to multiply these by 1. So you get 3,600 here. And, I'd have to use a calculator and figure these out myself. This one's a little bit of a challenge here. But copy it down, and in fact, I will tell you what you have to multiply it by. And the answer here is you have to multiply this fraction by 1 in the form of 20 over 20, and this fraction by 1 in the form of 3 over 3. So you get your common denominators, and you're going to subtract the numerators here, and then this gives you the final answer. Now, this is odd, and this is even, so you can't take a 2 out, and this happens to be a prime number. So that is the answer. So if I give you this, again, you could have this worked out. And did I work that one out? Yeah, it is worked out, and I see that is in your booklet. So I gave you a little break on that one. All right, let's go on here. Now, for multiplication, can we cross-cancel anywhere? No. So this will be 21 over 40. And for this one, yes, we can do some cross-canceling. 5 goes into there once. 5 goes into there twice. 3 goes into there once. 3 goes into there 6 times. So this becomes 1/12. And here are the answers there. With A and B. Be sure to have this. And if needed, to show the work. Again, I like to do the cross-canceling. You don't get any of these big numbers here. Now, for division, let's do these. And you can follow along or show the work. So 3/5, change this to multiplication, 15/7. 5 goes into there once, 5 goes into there 3 times, so we end up with 9/7. And this is an improper fraction, but that's fine. Now notice we're dividing a negative by a positive. So our answer is going to be negative. So remember to keep that negative sign. So this is going to be 4/7 times 14/3. Changing the signs, flipping that, we can cross cancel. We then get a negative 8/3 for this one. Now, keep in mind this is over 1 here. We don't write the 1 usually, but if you're going to do something like this, think of it that way. So this is going to be 2/9. Change the division to multiplication, flip that. And this becomes, You can cancel a 2 out of there, a 2 out of there. So this is going to be 1/18. And again, this is a -9/1. So, and negative and divided by a positive, this answer will be negative. So we'll put that there. And this is going to be a negative. We already showed that, so let's not write it twice here. Trying to speed this up a little bit here. So this becomes 9 now, over 1, times 5/3. Flipping that, 3 goes into there once, 3 goes into there 3 times, so a -15. Again, you have to practice to develop the skill. That's what we're doing here. And there they are, all worked out for you. Now in your homework logs, of course, this is the type of work I expect you to show. Okay, let's find the arithmetic mean, and I'll go through it with you. So, 2/3 and 5/6, all divided by 2. We'll do the top part first. Our common denominator is 6. So we have to multiply this by 1 in the form of 2/2. So this becomes 4, 6 plus 5, which is 9/6. Now I could simplify that, and this is going to become 3/2. Alright, so 3/2 is the equivalent fraction. But now I have to take half of this, that is, multiply it by 1/2, and this becomes 3/4. And that's our protocol for doing it. And there it is, 3/4. 3/4 is halfway between 2/3 and 5/6. But remember, there's an infinite number of fractions between any two numbers. Just a concept in mathematics. Okay, another type of problem. We didn't illustrate this in our PowerPoint slides, but, every once in a while we get one like this. And you want to find the arithmetic mean. Well, the arithmetic mean, and we'll just follow along with what they're showing us here. We write the individual parts of this all over a big common division bar. And there are 1, 2, 3, 4, 5, 6. To find the average, we add up all our numbers and divide by the number of scores or groups that we have. And in this case, it's 6. So it's this over that, and then this is our answer. Now remember, our numbers, though, are in thousands. So you could write it this many thousands, or take this number and just add the 3 zeros. So be sure, again, you have this. If this were a quiz question, I would say example 6 from our booklet, as opposed to the PowerPoint slides. Now, I should mention, you have to be careful here because some of the numbering of examples in your printed booklet are a little different than what we're showing here. Apparently, when they changed things around a little bit, they moved some of the examples, so we will go by our video, and if I'm going to use this on a quiz, I will try to be sure you are on the right example. Now, this example 7 here in our booklet, they're calling it example Well, the previous one was example 7 in our booklet, and this one is example 9, I believe. Yes, this is example 9. So we'll have to tweak that a little bit and watch out for that, because there's a little bit of confusion. I don't want to mess that up too much here. Okay, but let's go on. Now, I do have a number 6 in the booklet, so I've kind of written it up here. We have a piece of wood that's 72 inches long, and we want to cut it into 10 pieces. So there's going to be 9 cuts. So I want to take, and each cut is 3/16 is the width of the saw. So I have to multiply by the number of cuts, which is 9, times 3/16, and I get 27/16. Now I'm going to subtract this from a length of 72. Well, I borrowed 2 whole inches to show it as 32/16. When I do the subtraction of 27/16 from 32/16, I get 5/16. So this is what I have left. Now, what will be the width of each of these 10 blocks then? Well, I have to divide the 70 and 5/16 by 10. Convert this to its mixed number form, divide by 10, which is to multiply by 1/10. And I reduce it to this, and I end up with 7 and 1/32 is the length of each of these little pieces. So just copy this down, and you'll have that as an example for number 6 in your booklet. Okay, now you can pause and go back, but we're going to clear this up now, because we want to do number 7, which I believe is parallel to number 9 in your booklet. So let's be sure of that. So I did a similar thing to what I've done before, tease the denominators into their prime factorization. So 8 is 2 times 2 times 2, only 2's, so this will be a terminating decimal. Now as we look at B, and I took the 150 and found its prime, I have a 2, a 3, a 5, and a 5. Now the 2 and the 5's would be good, but there's also a 3 there. So this is going to be repeating. Now this one's a little tricky, because when I did the 75, I got 3 times 5 times 5. But is this fraction in its simplest form? And the answer is no. There's a 3 times 2 up there. So one of these 3's are going to cancel out. So this then really becomes 2 over 25. So our new simplified denominator is 25, which is only made up of 5's. So this is a terminating decimal in its fractional form. All right, let's check the book out here. This is running a little long, but a lot of good stuff. And there it is. You can pause. Now here, they'd like you to write each terminating decimal as a quotient of integers. So they want you to write it in fractional form. Now this example is not in our booklet, so you'll have to write this over on the notes side. This is like an additional example 8. But just a little bit of background on converting decimals into fractions. And what we're doing here is putting This is 437 thousandths. So putting it in its fractional form, and this is a prime number, so it can't be simplified in regard to its thousands denominator. But here, this is, again, over 1. So if we multiply the top by 10 over 10, this will move the decimal over 1, and we add a decimal place, and we get 8.2 is actually 82 over 10. And we can take a 2 out of each one since they are even. So this is 41 over 5. So if we were going to ask on a question like this, I would put this up on the board there on the screen, and we would simplify. All right, let's go on. And there we see it worked out. Now, this one is a little higher level, so I will show it to you, but we're not going to actually have one like this in our lesson. It's a little bit too advanced for what we're doing. But here's what it looks like. And you see why we're not doing it. They're using the algebra to say x equals this, and 100x then will equal this. When you do the subtraction here, you get 99x and you end up with just an 85. And you divide both sides by 99 here, and you get 85/99. Again, this is a little more challenging than what we're going to do. So I don't believe this one is in the booklet. No. So we don't have to worry about this one at all. And that will complete our lesson. There is another one in the booklet, which we're calling number 8. And this is running a little long, so I'll do it quickly here. And there's a nice picture in your booklet, so it says, and write this in your booklet, because this one is there. We have 2 socket wrenches that are 1/2 and 3/8, and we want to find the value between it, the arithmetic mean. So we're going to add these two, divide by 2, and find it out. So in order to add these tops, we have to multiply this by 4 over 4 to get it to be an equivalent fraction with the denominator of 8. So 4 times 1 is 4, 2 times 4 is 8. So we got 4 plus 3 over 8, which is 7/8. We're going to find the number halfway between it, which is 7/16. So that'll wrap us up. And we did lots of good things here.